Well, we all experience its warmth and light, but did you know we can measure the power output of the sun? And with wax? Yes, that's right. I'm joined this morning with Mike Randall from the Wonders of Physics. What on earth are we talking about? Thanks for joining us.
Good morning. It's a pleasure to work with you.
Same to you.
I'm here to address a concern that I'm sure many of your viewers share these days. Is the sun broken? How would we know? It turns out this is an experiment that all of you can do at home.
Awesome.
You can actually measure the power output of the sun using blocks of wax and a few other simple things. This is it. This is basically it. If you go and get some, go to your local store, buy some wax. It comes in these cute little cubes. Put a sheet of aluminum foil between them, maybe wrap them with rubber bands, and you have created your own Joly photometer, named after John Joly, a very famous Irish physicist who invented this in the early 20th century. It works on this principle. The human eye is really good at telling the difference, like comparing things. So this device lights up, any light that hits this side makes this side glow.
Right.
Any light that hits this side makes this side glow.
Okay.
Because I know that there's going to be bright studio lights, it might be easier to see with this laser. So when this side's lit up, it makes that whole side glow. When that side's lit up, it makes that whole side glow. So if you have a light source that has a known power output, like a light bulb, like it says there's a label on the end, 60 watts. Okay, we know watts is how much power it's putting out. Watts, by the way, is energy per second. How much energy per second. So we know we have a known power source. We can measure with a ruler the distance from this to the center of this block. And then this is our stand-in for the sun today.
Okay.
Not much sun out here this time of morning.
No.
So the idea is you do this, by the way, not in a brightly lit TV studio. You do this in a room where you've got sunlight coming in and really no other light sources other than this one. Then you just move this back and forth until both sides of the block look like they're about the same. Like they're both lit up exactly the same.
Right.
And that's right about there. At that point, then you measure the distance in centimeters, I recommend, from your light bulb to there. You measure that distance. And then you do a little looking up. You have to look up the distance to the sun.
Right.
And I'll help you out here. The distance to the sun, between the sun and the earth, in centimeters, is about 15 trillion. That's a 15 with 12 zeros after it, okay? And you know the power output of your light bulb, you plug it into this little equation right here. As I don't freak out, it's just math, all right?
Easy enough.
It's
easy enough.
So if you want to know the power of the sun, you take the power of the light bulb, you take the distance to the sun, you square it with your scientific calculator, divide that by the power output of the light bulb squared, and you will come up with a reasonably good estimate for the power output of the sun.
Huh.
And that's something that really is not hard to do. I mean, anybody can do this. It's with stuff you probably have laying around the house or for maybe a couple dollars worth of
exactly.
materials.
This is very easy. Anyone could do this and great for all ages.
And it's not limited to just measuring the power output of the sun. Sometimes people say, like you get a compact fluorescent light bulb or an LED bulb, and it says it's 60 watt equivalent or 100 watt equivalent. How would you really know? You can actually use this apparatus and compare it. You can have two light fixtures, maybe the regular light bulb here and a compact fluorescent here, and you could do this similar experiment to see, are they really equivalent? So you can, kids, if you want ideas for science projects, you've got a science fair coming up, this might be a good one. Speaking of which, though, I do recommend if you do this, do it with an incandescent bulb. And I know that'll get a little bit harder to find.
Right.
Just trust me on that. You're comparing, if you do that, then you're kind of comparing apples to apples. The sun, light from the sun is from incandescence. It's glowing because it's hot. This is glowing because it's hot. Other light bulbs, like fluorescent bulbs and LED bulbs, make their light in a different way, makes them more efficient, but it's a little harder to compare.
Okay.
So.
Well, great experiment here. Thanks for coming in. We appreciate it.
My pleasure.
We'll be right back.